So here we have a question where a independent consumer advocacy group wanted to see if which drug had more active ingredients, the name brand or the generic brand. So they picked 10 random pharmacies and they sampled a drug randomly from each of them. Okay. Now, the important thing to know about this is that this is a matched pair scenario. Okay. So in our name brand category, there's pharmacy one, and also pharmacy one is also located in the generic brand. So like all of these are matched up. So the first thing we have to do, we have to get our differences. Okay. I'm going to do name brand minus generic brand because we want to see if name brand has more. So if I do name brand minus generic brand, we get -1, 4, 5, 13, 0, 7, 5, 8, 9, and 16. So this is going to be the data set that we're going to use throughout the course of this. Okay. So as I'm looking at this, we want to come up with a 90% confidence interval. All right. So first is our parameter of interest. We are trying to find the true average difference and we're looking for the active ingredient between the generic brand and the name brand drug. All right, assumptions and conditions. So the A, one, they do a random sample of the pharmacies. Yeah, they have a randomly selected pill from each prescription, and then 10 different pharmacies. Yep, so they have randomly selected pills. All right, so that's good to go. Independent. So they have 10 pharmacies. So 10 times 10 is 100. Assume more than 100 pharmacies. And then as far as normality is concerned, we're going to have to take a look at the normal plot. So you're going to go ahead and pull up your calculator, input this data set into list one. Oops. So we got -1, 4, 5, 13, 0, 7, 5, 8, 9, and 16. So second stat plot, got everything all set up here. Zoom 9. And that looks pretty linear. So what we're going to do is that we're going to make a rough sketch of that normal plot. So this is going to be a matched pairs T interval. All right. So this is the name of the test. Let's compute the interval. Okay, so the interval is, it's the mean of the differences plus or minus the t-score times standard deviation over square root of n. So let's go ahead and crunch this really quickly. So stat, calc, test, t interval. We have the data in there already. Our confidence level is 90%. Go ahead and run that. Little bits of information right here. So first off, besides the interval, it tells us that our average is 6.6. Our standard deviation is 2.57. So it's 6.6 plus or minus. We have to get a t-score. So we have 9 degrees of freedom. So we go to our t-table. We want 9 degrees of freedom at 90% confidence is 1.833. Standard deviation was at 5.27 over root 10. And just you want to indicate somewhere that the degrees of freedom are 9. All right. So then when I go ahead and look at this, 3.54 to 9.66. So 3.54 to 9.66. That's our interval. All right. Then lastly, we just have to interpret it. So we are going to say, I am 90% confident that the average difference in active ingredient between name brand and generic in milligrams, that's what the unit of measurement is between 3.54 and 9.66. Okay, part B is saying, based on your interval in part A, can you say there is a difference in the active milligrams? All right, so I have a little bit of room over here, so I'll kind of wedge this part in. And this goes back to the whole idea. So is there a difference? Well, remember, if there was no difference, 0 would be in the interval. So no difference is represented by 0. Okay, so since 0, which represents no difference, is not in the interval, I can say with 90% confidence that there is a difference between active ingredient in generic versus name brand. Cool. And that is that.